Alright, today we're going to look at solving these systems of equations. And right now, don't copy this down because I'm going to add these two equations together. And I want you to notice that when I go negative 2 plus 7, I get 5x. And 3 plus negative 9 gives me minus 6y. And negative 6 plus 9 gives me a positive 3. And so unlike yesterday when we did this, nothing went away. Nothing got eliminated. So this doesn't work yet. So we have to make it work. And the way we're going to do that, if you notice the title, it says we're going to multiply 1. And so what that means is we're going to have to pick one of these equations and multiply it by a number. So what you do is you can either pick the x or the y, but if I pick the x, I want opposites, and the easiest opposite to get here would be 14, and that would mean I'd end up multiplying both equations, and I don't want to do that. If you look at the y, I can turn this 3 into a 9, and so I'm going to multiply this top equation by 3. So when you do this, you got to make sure that you multiply each and everything by 3. So 3 times negative 2 gives me negative 6x. 3 times 3y gives me 9y. And 3 times negative 6 gives me negative 18. Now you can just rewrite the bottom equation, the one we didn't change. And now you can see that we have our opposites. And that's what we need to use this way of solving. So now we add them together, and these are going to drop out. So this goes away, which is what we want. And so negative 6 plus 7 just gives me 1x, or just x. And now I have different signs. So I have more negatives, so it's going to be a negative. And then you subtract 18 minus 9 gives me x equals negative 9. And so now you got to take this negative 9 and plug it into one of the original equations. I'm going to plug it into the bottom one, so I'm going to take it and put it into that equation. And so it's going to be 7 times negative 9 minus 9y equals 9. And so it gives me negative 63 minus 9y equals 9. And now we're going to solve for y. So now we add 63 to both sides. And this gives me, this goes away. Don't forget to bring down that negative, so negative 9y equals 72. Divide both sides by negative 9. And now I get y equals negative 8. So my point of intersection is a negative 9, negative 8. If you want to make sure you're right, you take that negative 9, you plug it into the top. So negative 9 times negative 2 gives me 18. The negative 8 times 3 gives me minus 24. And 18 minus 24 does equal negative 6. So it does work. So our answer here is negative 9, negative 8. So we'll call this one 1A. I want you to try 1B on your own. Make sure you have all the work shown in your notes. Alright, let's look at the next examples. We'll call this one 2A, this one 2B. And so as you look at this first example, we want to try to get our opposites. And so you can start with the x or the y, it doesn't matter. And so you take the small number and say, can I make it into the big number? So what would you multiply the 2 by to get 8? And the answer is 4. So we're going to multiply the bottom equation by 4. And so I get 8x, and then 4 times 3 is 12y. 4 times negative 8 gives us negative 32. And now just rewrite the top. So negative 8x minus 12y equals 26. And so as you do that, you might notice that I have two sets of opposites. And so when that happens, is 8 minus 8 becomes 0, 12 minus 12y becomes 0. And so I end up with 0 equals, and negative 32 plus 26 gives me negative 8. And so I have the situation where I have 0 equals negative 8, and that's false. And so when this happens, what we say is that there's no solution. And so if we were actually to graph these on our graph, what's happening is we have our two lines, and the problem here is that the two lines are parallel, and so they never cross. And that's why there's no solution, because they never cross. Now for 2b, we're going to do it together. So here, how am I going to take the small number, turn it into the big number? So I'm going to want that to turn into a negative 18. So I'm going to multiply the bottom by negative 2. And so negative 2 times 9 gives me negative 18x. Negative 2 times negative 7 gives me a positive 14y. And a negative 2 times 1 gives me a positive 2. Rewrite the top. And so here, the left side is just like what happened over here, where we end up with 0, because we have opposites, opposites. But now in this one, you'll notice that on the right-hand side of the equal sign, we also have opposites. And so now, goes away, so it gives me 0, and 2 minus 2 is 0. And so 0 does equal 0. And so this one is actually true. That's a true statement. So when I get a true statement, I'm not going to say no solution. And so what happens here, if we were to graph these two lines, I graph my first one, and then when I go to graph my second one, it actually turns out to be the same line right on top of it. And so when we get a problem that says 0 equals 0, we say true, but now we say many solutions, because there's more than one point on the graph that would work. You can say many solutions or infinite solutions, but we'll just go with many solutions for now.